Lesson 13.7, Part B. Now here we have two functions occurring, tangent, lowercase, and cosine, capital C. So again, they're looking for cosine inverse, and it's 4/5. Now remember, 4/5, we have to ask ourselves a question. Is that degrees, or radians, or what are we looking for here? Now, 4/5, cosine inverse of 4/5 is where we would use our calculator and take actual cosine of 4/5 here. Now remember, cosine is between 0 and pi, right? Or 0 and 360, or excuse me, 0 and 180. And pi we're going to say is 3.14. If we do cosine inverse of 4/5 on our calculator, we will get 0.6435. Now, is that between 0 and 3.64? Yes, it is. So that is okay. That satisfies the capital C window. Now, what is tangent of that? And again, we can just use our calculator for that. Tangent of 0.6435 is 0.75. And that is our answer. Now, two more questions. We have a combination of trig functions here. Again, arctan. Arctan is the same as capital T tan inverse, which has a requirement. Tangent, if you remember, is negative 90 to 90. Or in this case, we're talking about radians, so negative pi over 2 to pi over 2. So what gives us root 3 over 3? And on the unit circle, that is pi over 6, or 7 pi over 6. But tan, capital T, only goes from negative pi over 2 to pi over 2. So this one is outside that window. So this is arctan of root 3 over 3. So now we have sine of root 3 over 6. Excuse me, sine of pi over 6. What do we get for sine at pi over 6? Check your unit circle. And pi over 6 sine is 1/2. Alright, now again, always notice we have lowercase t. So just asking you, what is tangent of pi over 4? Tan of pi over 4 on the unit circle is 1. Okay, and now we're looking for sine inverse. Well, sine is capitalized. So sine goes from negative 90 to 90, or negative pi over 2 to pi over 2. So when is sine 1? And that is 90 degrees. And that's the only place sine is 1, actually. And then that is our answer. In degrees, of course. Noticing that they ask for radians, we would say pi over 2. Our last piece is to take a function, or an equation, tan A equals B, and write it in the form of an inverse function. Now, if you remember from earlier, if we do tan inverse, the tans cross out, we get A equal to tan inverse of B. Or we said that that is equivalent to arctan of B. Both are acceptable notations. Now this ends lesson 13.7, part B.